Hi, my name is Hawk Hill, and I'm here to welcome you to this exploration of Saguaro and Petrified Forest National Parks, located in Arizona. On the left, we can see the two parks and they're relative to each other geologically, referring to bibliography A1. In this presentation, we'll dive into the geological histories of these two incredible parks, focusing on their formation during the Proterozoic to Mesozoic eras and the late Triassic period. Though separated by distance, these parks share a history shaped by geological processes, ancient climates, and human interactions. In the first image on the right, we are able to see the beautiful Blue Mesa Badlands that are located in Petrified Forest National Park, referring to A3 in the bibliography. First, we have Saguaro National Park. It is located in southern Arizona outside of Tucson. This national park has two districts, one containing the Rincon Mountains and the other the Tucson Mountains, and is home to the beautiful saguaro cactus as we can see above image A2. The park has a geological history dating back to as early as the Proterozoic era, about 1.6 billion years ago. Basement rocks like granite and gneiss formed deep down within the Earth's crust. Tectonic activity was seen increasing sometime during the Mesozoic era. These activities result in an upheaval of volcanoes and the beginning of mountain building. These layers combine with sedimentary rock deposits and contribute to the basin and range landscape. For bibliography Q1. Secondly, we were able to take a look at the Petrified Forest National Park. Located in East Arizona outside of Flagstaff, which has a unique geological history. During the late Triassic period, around 220 million years ago, this region was a lush floodplain with low-flowing rivers. Over time, trees fell into the water and were buried by volcanic ash, leading to the preservation of wood as petrified stone through permeabilization. After this process, as we see in the image above, wood becomes a beautiful color with a stone-like texture. The park's famous colorful rock layers were formed as ancient rivers deposited vast amounts of sediment. Article Q2. The histories of these two parks seem to be very similar in more ways than one. Saguaro's volcanic rocks and mountain formations were shaped by uplift and faulting. On a different note, the petrified forest sedimentary layers are the result of ancient river systems that inserted a large amount of materials over time. Even though the parks are not necessarily close to each other on a map, they share similar tectonic histories. As seen in the image, Saguaro is a particularly dry desert environment. A2, articles Q1 and Q2. In both parks, using stratigraphy, we are able to see a drastic change in both of these environments. At Saguaro, we are able to see evidence of marine stratigraphy due to the deep limestone and sandstone layers. These rocks provide clues about a distant time when this whole area was covered by water. At Petrified Forest, we're able to see terrestrial stratigraphy, which gives us evidence of river sediments. Both parks also contain volcanic ash layers reflecting how volcanic activity impacted the landscapes in these parks. In the image, we're able to see the harsh spines that develop on the cactuses in Saguaro National Park, referring to A2 and A3 in the bibliography. Scientists have studied past climate change in these parks by discovering new fossils and taking a look at the different rock formations. During the Proterozoic to Mesozoic eras, the area saw different levels of temperature fluctuating and precipitation levels varied. In the late Triassic, the area around the petrified forest was much more wet, which helped promote the growth of dense forest. Though over time, the weather seemed to shift, causing Saguaro to become the dry region. As seen in the image above, it snows in the petrified forest where we can see it's wet, A4. Saguaro National Park was established in 1933 to help preserve the cactus in the park, along with the surrounding ecosystem. In the picture above, we can see a camper driving through this beautiful national park looking to visit. Over the years, human activities have affected this area, causing a decrease in life and negative impact on the soil. Conservation efforts focus on protecting the unique flora and fauna. Petrified Forest National Park was established in 1906 to protect the unique fossilized trees and ancient forests. Due to many early activities, such as fossil searching in this park and the use of land for development purpose, there was some damage caused to the park, referring to Article Q1 and Q2. The landscapes of both parks continue to evolve on an everyday basis thanks to erosion and deposition. In the petrified forest, erosion and wind are slowly able to peel back the layers of petrified wood throughout the years, revealing the beauty of the many layers within. Saguaro also goes through the process of erosion, still with the help of monsoons and constant shifting of the sand in the ecosystem. In the picture above, A2, we are able to see the beauty of the landscape with the dry climate and subtle hills. Looking ahead, with no change in our global warming, climate change is expected to speed up these processes. Warmer temperatures, decreased rainfall, and more frequent wildfires are projected to impact both parks. Bibliography Q3 and Q5. Volcanic activity has shaped the geology of both these parks. Petrified forests containing very well-known petrified wood showed a large variety of ancient plants and animals. Although the above picture is above of rock carvings, I thought they were absolutely fascinating. As you can see, the plants and animals represented in image A3. Fossils in both parks document the long progression of ecosystems from ancient life forms to modern species, providing a valuable look into Earth's fascinating evolutionary history. Articles Q1, Q2, and Q3. Finally, to sum it up, Saguaro and Petrified Forest National Parks provide a remarkable glimpse into the planet's history. Because of their similar volcanic activity, changing temperatures, and fossilized evidence of ecosystem history, their geological histories are intricately linked. Although climate change is posing challenges to national parks in the future, their preservation is essential to comprehending the past of our world. I appreciate you traveling with me as we explore the biological and geological marvel of these two outstanding parks. Finally, we'll end this presentation with a beautiful picture of a petrified forest sunset. A3.